Hello everyone, Alan Sens here, and welcome to this segment on the command and control of nuclear weapons. In this video, we're going to look at the United States command and control system to talk about both some general and US specific aspects of the command and control of nuclear weapons, obviously a very important subject. So let's get started. By the time we're done, you should be familiar with the motives behind nuclear command and control systems, and you should be able to describe how those systems work at a conceptual level. We're not going to get too technical here. Obviously, we'll talk about some of the technicalities, but this is a somewhat simplified overview of command and control. Let's look at command and control first from a more general military context. These are the two primary motives for command and control systems, because in general, all military command and control systems are designed to do two things. They're designed first to ensure effective communication between commanders at all levels, and second, to ensure effective control of the military by the political leadership. So right away we have some important insights into how nuclear command and control systems in particular have to work. There's been a lot written on this subject, as you can well imagine. Some older books written during the Cold War. Paul Bracken's The Command and Control of Nuclear Forces is a classic. More recently, if we're looking for a good book to read that was produced relatively recently, Eric Schlosser's Command and Control, I would highly recommend. It's a very good book. And in addition to being very informative, it's also something of a page turner. I think you'd like it if you're interested in this subject. Okay, let's look at nuclear command and control now. So there are a number of objectives with respect to nuclear command and control systems. The first objective is to ensure that nuclear weapons can only be used when there is an appropriate political authorization to do so. Obviously, we want that to happen because we want to make sure that only those authorized, only those who are political leadership, the highest levels of political leadership, can launch nuclear weapons. Secondly, we need to ensure that should political authorization be provided, nuclear weapons can be armed and launched in a timely fashion. It doesn't do any good if you get political authorization after 2 days. The whole idea is that the system can actually launch nuclear weapons fairly swiftly after you have that political authorization. Third, you want to ensure your warheads are not used by allies on whose territory your nuclear weapons may be based. So, for example, the United States did base nuclear weapons in countries around the world during the Cold War, and obviously didn't want its allies to be able to use them whenever they wanted to. So command and control systems were also designed to do that. And finally, you want to make sure that military commanders cannot launch weapons on their own initiative. You want to be absolutely sure that nuclear weapons are only used when you have political authorization to do so. Now, effective command and control systems must be able to prevent the use of nuclear weapons without right authority, and they must be able to ensure the effective and rapid use of nuclear weapons should that right authority be given. And so, to put it more simply, command and control systems are both triggers and safety catches. Okay, let's look at the US model. Now, the US model sort of has a fundamental concept to it, or philosophy, and that is the so-called two-man or two-person rule at both the political and military levels. The whole idea here is that no nuclear weapon should be authorized for use or launched without two humans in the loop. Now, at the political level, this is a little murky because the president has ultimate authority as an individual to launch the United States nuclear weapons. Nobody else has that authority. The whole idea, though, in the US system is that the Secretary of Defense must also give their consent. The Secretary of Defense cannot give authorization to launch. Only the president can do that. But the idea is the Secretary of Defense has to agree with the president, which raises the question, what would happen if the Secretary of Defense didn't agree with the president? Well, here's where it gets murky, because the Secretary of Defense, of course, serves at the will of the president. So if a president wanted to launch, Secretary of Defense says no, then the president could relieve the Secretary of Defense, replace them, presumably with someone who would say yes, and the authorization could be given. So this is just one example of how there are so many gray areas in the entire command and control dialogue. But one thing you should be absolutely clear on: the President of the United States has the ultimate authority to launch America's nuclear arsenal. Beyond that, once political authorization is given, there are a set of codes, political authorization codes, and then permissive action links or use control codes that are military. The political authorization codes and the military codes are different, but the political authorization codes activate the military codes. Let's take a closer look at this. So this chart, it's awfully busy, I realize that, and you may not even be able to read much of it, but don't get alarmed. I'm simply using this as a illustrative device. So this is Department of Defense, the structure of the Department of Defense, an org chart, if you like. So here's our Secretary of Defense right up here. So let's say the President has authorized the use of U.S. nuclear weapons. The Secretary of Defense has agreed. Under this arrangement, the responsibility for the actual use and launch of America's nuclear arsenal falls to Strategic Command, one of the combatant commands in the United States military. And let's use an example of one leg of the U.S. nuclear triad, the land-based part of the U.S. arsenal. And let's look particularly at the intercontinental ballistic missiles in the U.S. nuclear arsenal. So this map simply shows the location of United States ballistic missile fields in the U.S. You can see the states that are involved. So what we have now is we have the president giving the authority, and we would have then the codes coming to the military through the military system. And when they arrive at the warhead, each specific warhead has a set of codes that are unique to it. These are called permissive action links, or PALs. PALs enable warheads to be armed, to receive information on targeting, trajectory, and yield if the warhead is a variable yield warhead. So what we'll have here is we'll have the codes, the military codes, coming in from Strategic Command, and they might arrive by a number of different vectors. They could come from satellite communications, they could come from aircraft, they could come from ground-based antennae. It doesn't really matter. But the whole idea is then the codes come into the launch center at the ICBM field. In turn then, codes go out to all of the individual ballistic missile silos under the command of this launch center. So here, the whole idea then is the codes would arrive into the launch center of this intercontinental ballistic missile silo. It should be here. Here's the missile itself, of course, here. And the codes would go right up into the warhead, and if they were the right codes, they would activate the warhead. And this then would arm the warhead and allow the warhead to receive the kind of information that we just talked about earlier, trajectory, yield, and so on. Now, right at the warhead point, what we're really talking about then is the codes arriving here. excuse me, here, there we are, and going into the warhead, being received by the warhead, and then being converted into mechanical energy that allows, and electrical signals that allows the warhead to arm itself and fuse itself and so on. The warhead does have a set of safety systems built into it in the form of environmental sensors and tamper-proof membranes. So let's say, for example, someone decided that they want to try and drill into the warhead casing. The warhead would detect that, and it would deactivate itself. Conversely, if someone tried to heat the warhead up for some reason, so they wanted to make it very, very hot, the warhead would detect that and go, well, something's happening, and the environmental sensors then would make the warhead deactivate itself. So the whole idea is that only an authorized signal, the correct codes, is going to activate, arm, and set the warhead. And this is sort of a key part of this technology. This is a intent strong link, so signal comes in here and gets converted into both electrical and mechanical signals on this end here. And this is the actual device then which both arms and sets the warhead. And when it comes for launch, then the individuals in the control center and the missile control officers, these two here, will authorize the release of the weapon. They will check the codes, they'll make sure the weapon is ready, and then when they have verified that everything is okay for launch, they will then turn their switches simultaneously, and that launches the weapon. Again, two people, in this case two in the missile control center of the silo, have to give their approval. And in fact, there's another layer. The launch control officers in the main control center for this ICBM field also have to give their consent. So the whole idea is all along the way, you've got these codes that have to be right, and you've got these two people involved that also have to give their assent in order for a weapon to actually be launched. Okay, that's it. By now you should be broadly familiar with the motives behind nuclear command and control systems, and you should be able to describe how these systems work at a conceptual level. Okay, well, obviously, we could go into a huge amount of depth here, and people have, and command and control systems are inherently very complex, and there's a lot of questions about how robust they are. Could they be fooled? Can mistakes happen? The short answer is yes, mistakes can happen. And there's also questions raised about whether they're sort of dead persons triggers and so on. So it's the so-called doomsday triggers in some of these systems. We're pretty darn sure the United States does not have such a system, but there's been talk that maybe Russia does and so on. And of course, we've been very US-centric in this video. We know very little about the Russian command and control system, and we know even less about North Korea's, for example, or India and Pakistan. So a lot of these command and control systems are guided by the similar principles, but they're different in how they've been implemented and what the mechanics might be. I hope you enjoyed this video. We'll see you again soon.